progression is obviously going to be, once we find the volume of prisms and cylinders, that we're going to find the volume of pyramids, cones, and spheres, some of the other shapes. So as you look at these two, they have congruent bases, the heights are the same, but obviously their volumes are different. You can put a lot more in the prism on the left than you can in the pyramid on the right. So let's figure out how much. Now, if you're in class, we're going to do an investigation where we fill up these shapes with rice, and you're going to watch your classmates spill rice all over the floor, and they're going to be given a dustpan. They have to clean it all up. So what they're going to do is they're going to choose a prism and the pyramid with a congruent base and height, and they're going to fill up that prism, or fill up the pyramid and pour it into the prism, and they're going to think, okay, it looks like about a third of the prism is filled by dumping in the entire pyramid's contents. And then we'll do it again. We'll fill it up 3 different times. We'll do the same procedure for the cylinder and the cone. We're going to take the cone and fill it to the top with rice and pour it into the cylinder. And it will take 3 times of dumping the cone's contents into the cylinder to fill up the cylinder. So that's going to motivate us to come up with this idea of the volume formula for a pyramid or for a cone. And again, we'll use big B for the area of the base. We'll use big H for the height. So the volume is going to be 1/3 the area of the base multiplied by the height. So volume of a pyramid or a cone is 1/3 the volume of the prism or the cylinder, whose base area and height are exactly the same. So this was the 1/3 times base times height. Let's do a couple practice problems. Pause here if you want and try the first one. So I got myself a pyramid. It looks like it's a rectangular type of base. So the volume is going to be 1/3 times the area of the base. The base looks like it's a rectangle, maybe a square, so we'll do 4 times 4. The height is 6. We'll multiply these together. 4 times 4 is 16. 1/3 of 6 is 2. So our volume is going to be 32 square units. Try the second one. Hit pause if you'd like. So the second one's a little bit different, because notice that the 26 is what's called the slant height. It is not the height of the cone. It's the height of the side of the cone. This would be the height of the cone. So notice that it makes a right triangle. So in order to find the height, I'm going to first have to do the Pythagorean theorem. And I think when we solve this Pythagorean theorem, 26 squared is 676. 10 squared is 100. When we subtract them, we get h squared equals 576. When we take the square root of both sides, the height turns out to be 24. So now we can go to our volume. Our volume is 1/3 the area of the base. Now the base is a circle, so it's pi times the radius squared multiplied by the height of the cone. We found that to be 24. So if we do some calculations here, I know that 1/3 of 24 is 8. 10 squared is 100. So my volume is going to be 800 pi, and I think my units are meters. So that is a huge cone. It's 24 meters high. Oh my goodness. And again, we can leave our answers in terms of pi. That's always acceptable. So take a look at this problem if you'd like. Hit pause again and see how you do. All right, so it's a pyramid with a square base. So the base is a square of side length 12. And now I know the whole volume is 864. So if I write my volume equation, it's going to be that the volume is 1/3 times the area of the base times the height. So I got to solve this equation. So you can evaluate the left side a little bit. 1/3 of 12 is 4. 4 times 12 is 48. So 864 equals 48 times h. When we divide both sides by 48, we get the height to be 18. So in these volume equations, we can solve both for the volume, or we could use the volume to find a height or a radius or another dimension. So let's move on now to spheres. And we're going to do spheres kind of the same way, but notice the setup for the sphere that we have. we're going to compare a sphere whose radius we're going to call some length r. So then the diameter of the sphere is 2r. And we're going to compare it to a cylinder that has a height of 2r and a radius of r as well. So it's the smallest cylinder that encloses a given sphere. Think of like a tennis ball in a can or something like that. So we're going to proceed the same way. We're going to take our sphere and make a hemisphere. We're going to take half of it. We're going to pour the contents of the hemisphere into the cylinder. And it looks like the cylinder is about 1/3 full. So if we fill it again, now we've poured a whole sphere into it. It looks like it's 2/3 full. So the idea is that it looks like it's 2/3 of the volume, or the sphere is 2/3 the volume of the cylinder. So if I'm going to write a volume of that cylinder, okay, I know it's going to be volume equals pi times the radius squared, and the height is 2r. So I'm going to multiply it by 2r. And when I kind of combine some like terms, what I get is that my volume is 2 pi times radius cubed. Notice I multiply r squared times r, and I get r cubed. So now the volume of this sphere is the fraction of the cylinder's volume. So the volume of the sphere is 2/3 of the volume of that sphere. So if we multiply 2/3 times 2, we get 4/3. So the volume of a sphere is 4/3 pi times r cubed, which should make sense that there's only two variables in it. V is the volume, and r is the radius, because a sphere is like a circle. There's a radius, and that's about it. So that's how we'd find the volume of a sphere. Well, let's practice a few. If you want to hit pause and play with some of these, we could do that. So for the first one, the radius is 6. So it's 4/3 pi times 6 cubed. I think 6 cubed is 216. When you multiply that and divide that by, or multiply by 4, divide by 3, our volume comes out to be 288 times pi. And again, it's in terms of pi. Let's leave it alone. And the last one, interesting, notice that this is a hemisphere. It's half of a circle, half of a sphere. So our volume is going to be 1/2 of 4/3 pi times 3 cubed. If you want to think of 1/2 of 4/3 as 2/3, that's cool. We could do that. And when we calculate this volume, 3 cubed is 27. 27 divided by 3 is 9. Times 4 is 36. Half of that is 18. And we stick a pi on the end. Or go to your calculator and figure it all out. And again, an answer like 18 pi is perfectly legit. Now let's work the other way. Instead of giving you a radius, what if I tell you what the volume is? And we want to find the radius of this sphere. Well, we can write an equation for it. The volume is going to be 3053.6 equals 4/3 times pi times radius cubed. And we have to solve for r by undoing the equation. So instead of dividing by 3, let's multiply by 3. So I'm going to do 3053.6. I'm going to multiply that by 3. And then instead of multiplying by 4, I got to divide by 4. Instead of multiplying by pi, I'm going to divide by pi. So this expression here is what radius cubed is equal to. Now, let's talk about how to undo it. Because you know from earlier that if you have like r squared equals 16, if it's squaring, you take the square root. So if we do cubing, to undo it, we have to do what's called the cube root. And on a calculator, it would look something like this. The cube root, and then has like a square root symbol on it. That symbol is actually a root symbol. We just don't write the square root of a number, let's say. We don't put the 2 in there. We only change the number if it's not a square root. So that's what a cube root looks like. So my answer is going to be the cube root of this big fraction. So what I'm going to do now is I'm going to grab my TI Nspire calculator, and I'm going to figure out what that value is. Let's show you how to do it. So the way to find cube root is going to be right over here, which should make sense to you. Did you notice that like squaring and square rooting were inverses of each other? So what I'm going to do is to get the cube root, I'm first going to type 3, and then I'm going to go Control and caret. Okay, so I didn't have to press the 3 first. So let's go here and delete that, and let's go up in that box there and type a 3. So there's my cube root. Now, what's nice about this is you can type it in exactly as you see it. So I'm going to do my control division and get my fraction template. And I'm going to type 3053.6. I'm going to multiply that by 3. That's my numerator. And my denominator is 4 pi. And pi is down there. Now, if you don't have a calculator like one of these, and you want to type it all in, I would do this, 3053.6 times 3. I'd put that in parentheses, and then I would do divided by, and in parentheses I would put 4 pi. I'd get that number, whatever that number is, I think it's around 729. And then I would take the cube root of that number. That's what I would do in there. So let's see what that's going to look like. If I type all that in and press enter, I'm going to get about 8.9999 and a bunch of other numbers after that. So let's round this up to 9. So when I solve this, we get 9. So one of the things you should be able to do with a volume of a sphere is be able to work backwards and take the cube root to find the radius.